Hello Physics 111 class. Our names are Emma, Anjali, and Katie, and we research the physics of hula hooping. The motion of a hula hoop is a twisting rotational force. This is a great example of torque, the tendency of a force to rotate an object around an axis. 5 factors are at play when you hula hoop: an outward force, torque, friction, centripetal force, and gravity. You aren't just a hula hooper, you're the hoop's axis, the center of its rotation. Isn't that flattering? When you begin to move your hips with a hula hoop, the motion of hoop creates torque, a twisting outward parallel force. Mathematically, torque is defined as a cross product of the value of the radius of the rotating object and the force vector which produces the rotational motion.
However, because we cannot calculate the force of the person on the hula hoop, we are unable to use the general torque equation, torque equals Fr sine theta. Therefore, we decided to compare the torques of each hula hoop by examining the change in angular momentum. In rotational motion, angular acceleration is required to produce torque of an object, which depends on the distribution of the mass. The moment of inertia is a value that describes this distribution. It can be found by multiplying the mass of the object by the radius of the object. The units of torque are Newton meters.
Torque can be defined as the rate of change of angular momentum. Angular momentum is a cross product of the moment of inertia and angular velocity. In this case, angular momentum can be thought of as the amount of effort needed to keep the hula hoop spinning. Applying Newton's first law, we can conclude that the hula hoop will continue to rotate around the axis of rotation if angular momentum is conserved. If angular momentum were to increase, the hula hoop would rotate faster, making more revolutions per minute. Inversely, if the angular momentum were to decrease, then the friction between the hula hoop and the person, as well as the force of gravity, would cause the hula hoop to fall down. Overall, an outward force exerted on the hula hoop by the person and a centripetal force that causes the hula hoop to follow a curved path will overcome the forces of friction and gravity acting on the hula hoop, therefore preventing the hula hoop from falling to the ground.
For our project, we used 2 hula hoops of different masses to examine the difference in the amount of torque produced by each hoop. The blue-green hoop has a mass of 1.36 kilograms, and the pink hoop has a mass of 0.022 kilograms, each with a radius of 0.425 meters. We first calculated the moment of inertia for each hoop by multiplying 1/2 the mass of each hoop by the squared value of its radius. The moment of inertia for the pink hoop was 0.021 kilograms meters squared, and the moment of inertia for the blue hoop was 0.123 kilograms meters squared. Then we calculated the period of each hoop by calculating the number of revolutions the hula hoops made during a 60-second trial. We were then able to find velocity using the equation 2 pi r divided by t, the period. Using this information, we were able to find the angular velocity by dividing the velocity by the radius of the hula hoop. The angular velocity of the pink hoop was 4.56 radians per second, and the angular velocity of the blue hoop was 4.75 radians per second. Lastly, we multiplied the moment of inertia and the angular velocity to find the angular momentum of each hoop. Since we started at rest, the initial angular velocity is 0, so the initial angular momentum of each hoop would be 0. The calculated angular momentum would then be equal to the change in angular momentum. The angular momentum of the pink hoop was 0.0958 kilograms meters squared over seconds, and the angular momentum of the blue hoop was 0.584 kilograms meters squared over seconds. We found that the heavier hula hoop has a greater change in angular momentum than the lighter hula hoop, which implies that the heavier hula hoop would have a greater torque. Therefore, the next time you are challenged to a hula hooping contest at summer camp, make sure to grab the heaviest hula hoop you can find.